Hello class. Today we're going to go ahead and take a look at solving compound and absolute value inequalities. So our target goal for today is that you will be able to solve compound and absolute value inequalities after we're done with this section. So let's just go ahead and start looking at the first example. One test used to determine whether a patient is diabetic is a glucose tolerance test. Patients start the test in a fasting state, meaning they have no food or drink except water for at least 10 but no more than 16 hours. Write the acceptable number of hours H for fasting by using an inequality. So if we think about it, we can be 10 hours, we can be 11 and 12, 13, 14, 15, all the way up to 16. Okay, so we need to write an inequality from that. So we all know that H has to be greater than or equal to 10. Okay, but, and it also has to be less than or equal to 16. Okay, has to be both of those things. So then we use the word and. Okay, so if I want to write a whole inequality, if I want to put these two things together, notice that 10 is less than or equal to H. Okay, and also H is less than or equal to 16. So here is my compound inequality that shows the number of hours. So let's just go ahead and look at some compound inequalities. So what that is two inequalities joined by the word and or the word or. Okay, so if we look at and inequalities, okay, they are true if and only if both inequalities are true. And notice they have the word and. Okay, so both things need to be true. Okay, so x has to be greater than or equal to -1, and x has to be less than 2. So that is shown here on the number line. Okay. Then when we use or, it's true if one or more of the inequalities is true. So they do not both have to be true at the same time. That is for the word or. Okay. So for this one, x is less than or equal to 1, or it is greater than 4. Okay. So you can have multiple parts on the number line. So compound inequalities. We're going to solve each part of the inequality, then graph the solution. Okay, so all we essentially need to do is solve this for x, and you can keep it all as 1. So I look at what I have here, what I need to get x by itself, and we do it on all parts. Okay, so I want to get rid of that 7, so I would subtract 7 from everything. Okay, so we all know 13 minus 7 is 6. I still write my less than sign. Now I'm going to have 2x is less than 10. Once again, now I want to get x by itself, so I have to get rid of the 2. In order to do that, I divide everything by 2. 6 over 2 simplifies to 3, 2 over 2 simplifies to 1, and 10 over 2 is 5. So this is our compound inequality. Now we need to go ahead and graph it. So draw a number line. You guys should have one on your worksheet. Okay. And so what we need to do is we need to do 3 is less than x, which x is less than 5. Okay, the easier way to look at this is just to start with 3. It is an open circle because it is not equal to, and it is also an open circle at 5. And if you look at the inequality, it's really saying that x is in between 3 and 5. So we shade in between there. Let's go ahead and look at the next example. I actually want you guys to do this one, pause the video and do this one on your own. It looks very similar to the one we just got doing. Make sure you graph it. Okay. All right, now we're going to go ahead and look at an or. So in order to look at an or, there is 2 inequalities here, so we're just going to solve both of them and then we're going to graph them. So it says x plus 5 is less than or equal to 7, so I subtract 5 from both sides. So x is less than or equal to 2, okay, just keeping this word or if I solve the other one, add 6 to both sides, x is greater than 8, okay. So x is less than or equal to 2, or x is greater than 8. There is my solution, but now we need to go ahead and graph it. at the first one. X is less than or equal to 2. Well, it's going to be closed circle at 2 because it's equal to. And to be less than 2 is to go to the left. Okay. Or X is greater than 8. So greater than 8, open circle. And to be greater than 8, we're going to go to the right towards the number 9, 10, and above. And so there is our solution graphed. Okay. Absolute value, though, of a number is the distance the number is from 0 on the number line. So just to refresh our memory, our absolute value of 7 is 7. Okay. And the absolute value of negative 2 is 2 because it is 2 units away from the number line. Okay. If I look at this next example, it says the absolute value of x equals 3. What we have to think about, is there more than one option? Well, I know that x could equal 3 because the absolute value of 3 is 3. But then I also have to think, well, it's always the distance, so what other number is 3 away from 0? Negative 3. And we all know the absolute value of negative 3 is 3. So this is something that we need to keep in mind when we're thinking about absolute values and inequalities. Okay, so just for example, we need to look at this one. Okay, absolute value of inequalities. So we have the absolute value of x is less than 4. So what we need to do is we need to think about, well, what numbers would fit this situation? Okay, well, obviously x being less than 4 would work. Okay, and let's think about what else would work. Okay, well, I know that negative 4, the absolute value of negative 4, would equal 4, but I want to also be less than 4. So if I think about numbers greater than negative 4, if I have negative 3, the absolute value of negative 3 is 3, and is 3 less than 4? Yes. So I would also want to have x's that are greater than negative 4. Okay. So once again, it would be, just to plug in an example, I have the absolute value of negative 2. Is that less than 4? Absolute value of negative 2 is 2. So yes, that is less than 4. So both of these would work for my absolute value. So let's just go ahead and write it as our solution. It has to be, from negative 4, has to be less than x, and x has to be less than 4. So there is my solution put together. Okay, let's go ahead and take a look at another example. Now we have the absolute value is greater than 4. Okay, well, I can start with the easy one. Obviously, x has to be greater than 4. Now we have to think about the number, the other values. Okay, so, or x well, we want it to be greater than 4. So I think about, well, what negative numbers, if I took the absolute value, would be greater than 4? Well, the absolute value of negative 5 is 5, so that's greater than 4. So I want my x values to be less than negative 4. So I could have either option. So if I went ahead and wrote this one out, this one's going to be an or statement because x can be greater than 4 or x can be less than negative 4. So here is my solution. Okay, I would like for you to graph the solutions for D and E. Okay, and one nice thing to know is a little trick. Okay, when we're dealing with absolute value and inequalities, if it is less than or equal to, you know it's going to be an and statement. Like part D, this is an and statement. Okay, if it's a greater than or equal to, like in part E, then you know it's going to be an or statement. Okay, so just to recap that, so it says if the absolute value of A is less than B, then it is negative B is less than A is less than B. So once again, if it is a less than, it is an and. Okay, and if I go ahead and this one is a greater than, then it is an or statement. Okay. Another way to remembering it, solving absolute value inequalities is a hint less than, so to end in We have less than, and it has the word and in it. Little hint. Same thing with greater than. If it is a greater than, it ends in the word sort of, or. Sounds like or. Okay, so that's one way to remember it as well. Okay, I think that's where we're going to stop today. So please make sure you take the video quiz and go ahead and finish up the problems on the note sheet that we did not do together. See you tomorrow.